So this is a differentiator. So differentiator is a circuit. Differentiator is a circuit which will give the differentiation of the input at the output. Already మీరు mathematics లో differentiation చేస్తున్నారు కదా. Differentiation ఏదైనా ఒక function ఒక wave form ఇస్తే input లో, what you will get at the output is the differentiation of that waveform. Differentiation of that waveform at the output. So for that we use an op-amp. Op-amp will be useful to get the waveform of any signal which is in the differentiated form. So here one capacitor is used and one resistor is used. So this differentiator circuit will, if you give an input of this type, we will get this output, and if you give this as the input, so we will get this as the output. That we will learn afterwards. Now, so here what are we going to give is Vi. So if Vi is given here, then the current entering into the junction and this current also entering into the junction, or you can write it as, because the current entering into the op-amp is considered as 0, so we can consider that whatever current is entering, the same current is leaving. In either way you can do the analysis. So if my current entering into this junction is Vi minus, here no current, Ib plus is equal to 0 అయితే ఇక్కడ 0 volts, ఇక్కడ కూడా 0 volts వస్తుంది. So Vi minus 0 by, and this C1, instead of C1, if resistor is there, we can use the resistor, but here we are having the capacitor, So how we can write this as, what is the current through the capacitor? Current through the capacitor IC is equal to C dV by dt. This is the formula. So what is the voltage? Voltage across the capacitor is nothing but, here the capacitor is C1, and voltage across the capacitor is nothing but difference between these two voltages, that is Vi minus 0 by dt. So this is the current IC. Now what is the current IF? IF is, here normal resistor we are having. So what is IF? IF is equal to V0 minus 0 by R. So what is the current at this junction? IC plus IF should be equal to leaving current. No leaving current is there, so 0. So here what is IC? C1 dVi by dt and plus V0 by Rf equal to 0. So what is V0? V0 is equal to minus C1 Rf into dVi by dt. So this is nothing but the voltage at the output. This is nothing but the voltage at the output. That is, the voltage will be multiple of C1 and Rf. This is the multiple, and the output voltage is the derivative of the input voltage multiplied with C1 Rf because the input is given to the inverting op amp, the negative sign will come. Okay. Let us check the waveform. If I give a sine wave at the input, if I give a sine wave at the input, then what I should get? What is the differentiation of sine? Cos. So what I should get? Cos wave I should get. So sine wave starts from, at the time t equal to 0, sine wave also will be 0. That is the sine wave characteristic. That means sine 0, 0, and sine 90 maximum, that is 1, and sine 180 again 0, like that it will travel. What will be the cos? Cos 0 will be 1, cos 0 will be 1, cos 90 will be 0. So, ila form, cos wave ila. But here, what are we going to see is that the negative sign is also there. As a cos wave, inverted wave వస్తుంది. అంటే ఈ cos wave invert అయితే ఎలా వస్తుంది? ఇలా వస్తుంది. So, అదే wave ఇక్కడ. So, output of this differentiator, if input is given, sine wave is given as input, then we will get inverted cos wave as the output. So, this is the differentiator. And if you give a square wave, then you will get spikes. You will get spikes at the output. So, differentiation of the square wave can be considered as this spike or impulse. అలా కన్సిడర్ చేస్తారు మీకు సిగ్నల్స్ అండ్ సిస్టమ్స్లో వస్తుంది. సో ఇక్కడ కూడా ఈ పాజిటివ్ హాఫ్ సైకిల్ ఆర్ పాజిటివ్ స్క్వేర్కి నెగిటివ్ స్పైక్ వచ్చింది. సో if this input is given to this differentiator, you will get this as the output. So this is about the differentiator. And now we are going to see the integrator circuit. Integrator circuit. And you can consider one thing, that differentiator is an high pass circuit. Differentiator is an high pass circuit, whereas integrator will be the low pass circuit.